Right now, an entire galaxy just disappeared. You cannot feel it happening. Your room is completely quiet, the shadows are resting softly against the walls, and the screen in front of you sits perfectly still. You feel nothing out of the ordinary. But while you are resting here, the universe is actively deleting parts of itself. It did not burn out. The billions of stars inside that galaxy did not suddenly explode or collapse into darkness. If you were standing on a planet inside that galaxy right now, your local sun would still be shining, and your night sky would look as perfectly ordinary as ours. But relative to us, to the exact chair you are sitting in and the planet you are currently spinning on, that galaxy has just slipped out of reality. It has crossed an invisible threshold. It has passed a boundary where the space between us and them is now stretching apart faster than the speed of light. The speed of light is the absolute speed limit of the cosmos, 299,792 kilometers per second. In the time it took you to hear that sentence, a beam of light could wrap around the Earth more than 7 times. It is unimaginably fast. But the space between galaxies does not have a speed limit. It stretches, and that stretching is actively accelerating. Because of that acceleration, the light that the galaxy is emitting right now, at this very second, is travelling toward us through a fabric that is growing faster than the light can cross it. Think of it like a runner sprinting on a moving sidewalk. If the sidewalk is speeding up faster than the runner can sprint, the runner will never reach the end. The light from that galaxy will never arrive. The information is permanently deleted from our causal reality. This is confirmed science. This is established by the data we collect every night. Right now, you are living inside a universe that is evaporating at its edges. Every second that ticks by, more stars, more planets, and more complete star systems cross over that mathematical horizon. They move from the realm of the visible into a permanent, untouchable absence. They are gone, and we will never get them back. Imagine standing on the deck of a ship in the middle of a vast, calm ocean at night. You can see the lights of other ships scattered around you, stretching out for miles. Now imagine that the ocean itself is expanding. The water between you and the other ships is multiplying. The farthest ships are pushed away so quickly that their lights slip over the horizon. You know they are still out there, sailing in the dark, but their light will never reach your eyes again. The ocean has grown too vast. That is exactly what is happening to the night sky above your roof right now. The fabric of the cosmos is expanding, and the horizon of our reality is actively shrinking. If you enjoy deep investigations like this, subscribe now. The investigation starts here. We like to think of the universe as a static museum. We look up at the stars and assume that the vault of the heavens is a permanent fixture, waiting patiently for us to invent the right telescopes to see it all. But the universe is not waiting for us. It is a dynamic, shifting environment, and we are inside it right now, losing access to it with every breath you take. When you look deep into the night, you are not looking at the universe as it is. You are looking at a delayed echo. You are looking at light that has spent millions or billions of years crossing an ocean of expanding vacuum. If a star is 10 billion light years away, you are not seeing it as it is tonight. You are seeing a ghost. You are seeing it as it was 10 billion years ago. The light entering your eye right now is a physical fossil. But the deletion of a galaxy is entirely different from the delay of light. The delay is just a matter of waiting. The deletion is permanent. Because dark energy is accelerating the expansion of space, there is a hard mathematical line drawn around us. It is called the cosmic event horizon. It currently sits about 16.6 billion light years away from where you are currently resting. 16, 6 billion light-years. Give that number a moment to settle. To cross that distance, a photon has to travel at the absolute maximum speed allowed by physics for a time longer than the current age of the entire universe. Anything beyond that specific line is moving away from us faster than its light can ever travel back to us. It has crossed a threshold of absolutely no return. This is not speculation. This is what the data says. You might feel a quiet unease at this. It is a strange thing to realize that the universe is not just vast, but aggressively isolating. That right now, unseen forces are pulling the cosmos apart, walling us off from the majority of existence. You cannot see the horizon moving. The stars outside your window look exactly as they did yesterday. The ground beneath your feet feels solid. Your breathing is steady. But the math insists that our cosmic neighborhood is being quarantined. There is a deep, quiet, existential weight to this. We are sitting on a tiny rock, orbiting a completely average star inside a local bubble that is drifting through an expanding void. The boundaries of what we can know are defined by the speed of light, and the speed of light is losing the race against the expansion of space. Every night, there is slightly less of the universe available to us. Every morning, another piece of reality has been carved away. Think about the sheer amount of information contained in a single galaxy that crosses this threshold. Billions of stars, trillions of planets, oceans of dust and gas, massive storm systems on gas giants, the silent orbit of moons in the dark, perhaps even the glow of distant worlds from a civilization we will never meet. All of that is physical information. All of it is bound by the strict laws of physics. When a galaxy crosses the cosmic event horizon, it is fundamentally severed from our reality. Causality itself, the fundamental rule of cause and effect that holds the universe together, breaks down completely between us and them. Because no physical signal can ever bridge the widening gap, nothing that happens in that galaxy can ever affect us, and nothing we do can ever affect them. Physics tells us that if two regions of space can never exchange information, they are no longer part of the same causal universe. The universe is actively fracturing, and yet as you sit there, surrounded by the quiet comfort of your room, you are completely shielded from this cosmic violence. The gravity of our planet holds you securely in your chair. The gravity of our sun holds the Earth in a steady, predictable orbit. The gravity of our local galaxy cluster is strong enough to keep our immediate cosmic neighbours tightly bound against the expansion. Locally, we are safe. Locally, the universe feels calm, structured and permanent. But that local calm is merely an illusion. We are living inside a tiny, localized bubble of stability, perfectly insulated from the grand quiet erasure happening out in the deep dark. This phenomenon does not ask for our permission. It does not announce itself. The universe simply proceeds, entirely indifferent to our presence, executing the laws of thermodynamics and cosmic expansion with silent precision. Right now, another star system just slipped away. Right now, another world is gone forever. You are a passenger inside a universe that is actively hiding its own history. Look up at the night sky. If you were to step outside right now, away from the glow of city lights, and stand in an open field, you would see thousands of stars glittering against the dark. It is a view that feels endless. It feels like you are staring into the infinite depth of the entire cosmos, a vast and permanent ceiling that has watched over humanity since we first learned to look upward. But what you are looking at is an illusion. The night sky, as you experience it, is not the universe. It is barely even our local neighborhood. Almost every single star you can see with your naked eye is located within our own Milky Way galaxy, and the vast majority of them are within a few thousand light-years of Earth. You are not looking at the grand structure of reality. You are looking at the immediate dust floating in your own local room. To understand what is actually out there, and to understand the specific invisible boundaries that are currently trapping you in your chair, we have to escalate the scale. We have to walk outward from the quiet stillness of your immediate surroundings into the deep dark. Start exactly where you are. You are sitting in a room on a planet made of rock and iron, orbiting a completely average yellow dwarf star. The distances here are already difficult to comprehend, but they are governed by a strict, unbreakable rule: the speed of light. Light is not just an image, it is a physical messenger, and it takes time to travel. When you look at the moon, you are not seeing the moon as it is right now. You are seeing it as it was a little over 1 second ago. When you step outside into the daylight and feel the warmth of the sun on your skin, you are feeling sunlight that left the surface of the sun 8 minutes ago. You are always, inevitably, experiencing a delayed version of reality. Now, push further out. The nearest star to our solar system is Proxima Centauri. It is located 4.2 light-years away. This means that the light leaving that star right now, at this exact second, will spend more than 4 years crossing a silent, freezing vacuum before it eventually strikes the lens of a telescope on Earth. If we pull back even further, leaving our local stellar neighbourhood entirely, we see the full structure of the Milky Way galaxy. It is a swirling disk of gas, dust, and between 100 billion and 400 billion stars. It is unimaginably vast, stretching roughly 100,000 light-years from end to end. If you could send a radio signal from one side of our galaxy to the other, moving at the absolute speed limit of the cosmos, it would take 100,000 years to arrive. But the Milky Way is not the universe. It is just one single structure, drifting in an ocean of empty space. If we escalate the scale again, we enter the local group. This is our immediate galactic neighbourhood, containing our Milky Way, the Andromeda Galaxy, and dozens of smaller dwarf galaxies. The distances here are no longer measured in thousands of light-years, but in millions. The light from Andromeda has been travelling for 2.5 million years just to reach your eyes. Keep pulling back. The local group is just a small suburb within the Laniatea supercluster, a massive web of thousands of galaxies all flowing along invisible gravitational currents. And Laniatea itself is just one minor thread in the grand cosmic web, a colossal structure of galaxy clusters and massive voids that stretches out in every possible direction. As we escalate this scale, zooming out past millions and then billions of light-years, you might expect this web to simply go on forever. You might expect that if you just kept looking further and further, there would be no end to the galaxies, no limit to the structure. But there is a limit. There is a hard, absolute boundary that you cannot see past. This boundary is not a physical wall in space. There are no bricks, no glowing force fields, no sudden drop-off into empty blackness. If you were standing at that boundary, the space around you would look exactly like the space surrounding our own solar system. Instead, the boundary is made of time and the finite speed of light. Because the universe had a beginning, a moment roughly 13.8 billion years ago, when space itself began to expand, light has only had 13.8 billion years to travel through it. If a galaxy is so far away that its light would require 20 billion years to reach us, we simply cannot see it. Its light is still in transit, it has not arrived yet. This creates an absolute limit to our vision. We call this limit the observable universe. It is a tiny localized bubble. Currently, the radius of this bubble, the distance from your chair to the absolute edge of what can possibly be seen, is about 46.5 billion light-years in every direction. Give that number the space it demands. 46.5 billion light-years. You might wonder how we can see 46.5 billion light-years away if the universe is only 13.8 billion years old. The answer lies in the fact that space itself is stretching. The light that has been travelling toward us for 13.8 billion years was emitted by objects that were much closer to us when the light began its journey. But as the light moved through the vacuum, the space beneath it was actively expanding, stretching like a rubber band. Today, the objects that emitted that ancient light have been pushed roughly 46.5 billion light-years away from where you are sitting. When you double that radius, you get the full diameter of our reality. We are living inside a sphere exactly 93 billion light-years across. 93 billion light-years. A single light-year is approximately 5.88 trillion miles. Multiply that by 93 billion. This is a distance so unfathomably immense that the human brain lacks the biological architecture to truly picture it. These 93 billion light-years contain all the quarks, quasars, stars, planets, nebulae and black holes that we have ever recorded, and everything else that we might be able to observe but have not yet seen. It contains an estimated 2 trillion galaxies. This is confirmed science. This is not speculation. This is measured directly by the data we collect from the cosmic microwave background and the redshift of distant galaxies. If you enjoy deep investigations like this, subscribe now. The investigation starts with the realization of your exact position within this incomprehensible scale, because here is the most unsettling part of this entire structure. The observable universe is not a fixed place. It is not an objective container that holds all of us inside it. It forms a sphere around the Earth, not because the Earth is at the centre of the universe, but because every single observer, wherever they are, has their own observable universe centred perfectly on their exact position. Right now, you are the absolute centre of your own 93 billion light-year bubble. If there is an alien civilization living in a galaxy a billion light-years away from us, they are not looking at the same bubble we are. Their observable universe is shifted a billion light-years over. Their horizon encompasses galaxies that we can never see, and their sky is missing galaxies that are currently visible from your window. The edge of their bubble is different from the edge of your bubble. Your horizon is entirely personal. It is defined not by location, but by light's long, slow journey, specifically to your eyes. This means that you are trapped. You are a prisoner inside this specific 93 billion light-year sphere. You cannot leave it. You cannot look past it. If you were to get in a spaceship capable of travelling close to the speed of light and fly toward the edge of the bubble, you would never reach the edge. The bubble would simply move with you, always keeping you pinned exactly in its dead centre. The horizon would constantly shift, revealing new galaxies ahead of you and swallowing the galaxies behind you, ensuring that you always remain the focal point of a sphere of visibility that you can never escape. And this bubble is actively isolating you. Remember the scale we just built. The Earth orbiting the Sun. The Sun drifting through the Milky Way. The Milky Way suspended in the cosmic web. All of it is contained within your 93 billion light-year sphere. But because of the accelerating expansion of space, the very fabric of this sphere is being stretched apart. You are sitting in a room that feels perfectly still. Your breathing is calm. The gravity of the Earth holds you firmly in place, and the air around you does not move. But at the edge of your personal bubble, space is behaving with quiet, violent indifference. Galaxies located near the edge of your 93 billion light-year sphere are currently being carried away from you by the expansion of space at speeds that exceed the speed limit of light. Because space itself is expanding, it is not bound by the rules of ordinary movement. The distance between you and those distant objects is increasing so rapidly that the light they are emitting right now will never be able to cross the expanding gulf. You are trapped inside a bubble of light, and the walls of that bubble are fundamentally shrinking in their causal reach. You are completely walled off from the true immensity of the cosmos. Every night you look up at the stars, you are looking at a comfortable, localized illusion. You are looking at a delayed echo of a tiny neighborhood, while the true scale of your reality remains invisible, untouchable, and permanently separated from the chair you are sitting in. We are not standing on the stage of the universe. We are locked inside a 93 billion light-year viewing room, and the curtain is slowly, permanently closing. If you want to understand the true boundaries of the reality you are currently sitting inside, we have to look as far away as the laws of physics will permit. But when we look deep into the dark of the night sky, we are doing something fundamentally strange. We are not just looking across vast distances of space. We are looking backward through time. Because light takes time to travel, your eyes are effectively functioning as a time machine. When you look at the moon, you are seeing it as it was a little over 1 second ago. When you feel the warmth of the sun on your skin, you are feeling sunlight that left the surface of the sun 8 minutes ago. If you look at the Andromeda galaxy through a telescope, you are seeing light that has been travelling through the freezing vacuum for 2.5 million years. This is an unbroken rule of the cosmos. The further away an object is, the further back in history you are seeing it. So, what happens if we push this rule to its absolute limit? What happens if we use our most powerful instruments to look past the nearest stars, past the distant galaxies, and past the massive swirling superclusters that make up the cosmic web? You might expect that we would eventually look so far that we would see nothing at all. You might imagine a vast, empty void stretching endlessly into the dark. But that is not what happens. Instead, at the very edge of our vision, we hit a wall. This is not a physical wall. There are no bricks, no barriers of stone, and no glowing force fields marking the end of the universe. If you were somehow transported to that boundary right now, the space around you would look exactly like the empty space surrounding our own solar system. Instead, this boundary is a wall of light. It is a glowing, omnipresent barrier of radiation that completely surrounds us in every possible direction. It wraps around the Earth, it wraps around our galaxy, and it wraps around our entire 93 billion light-year observable bubble. We call this the cosmic microwave background, or the CMB. This is confirmed science. This is not a theoretical boundary or a mathematical guess. It is a physical reality that has been mapped in extraordinary detail, measured directly. The cosmic microwave background is the absolute visual limit of our reality. It acts as a hard visual wall because it is not an edge in space. It is an edge in time. To understand why this wall of light exists, and why you cannot see past it, we have to travel back to the very beginning. We have to go to a time long before the Earth was formed, long before the sun ignited, and long before the first galaxies began to spin in the dark. We have to go back to the aftermath of the Big Bang. About 13.8 billion years ago, the universe was not the cold, expansive, and mostly empty place that you see when you look out your window tonight. It was unimaginably small, unimaginably dense, and blindingly hot. All the matter and energy that currently makes up the trillions of galaxies in our observable universe was crushed together into a searing, violent state. As the universe began to expand, it began to cool. But in its earliest stages, the cosmos was entirely unrecognizable. It was filled with a thick, glowing plasma. Imagine trying to drive a car through a dense, heavy fog. You turn on your headlights, but the beams of light do not travel very far. They instantly hit the thick water droplets in the air, scattering in every direction and bouncing back at your eyes. The fog is completely opaque. You cannot see through it. The early universe operated in exactly the same way, but the fog was made of pure searing energy. The universe was so intensely hot that atoms could not yet form. Electrons and protons, the fundamental building blocks of matter, were moving too quickly and violently to bind together. Instead, they swarmed in a chaotic, free-floating soup of charged particles. Inside this cosmic soup were photons, the particles of light. But the light could not travel. Every time a photon tried to move forward, it would immediately crash into a free-floating electron, bouncing off and changing direction. The light was trapped. The entire universe was a glowing, opaque, impenetrable fog of plasma. If you had been standing there, surrounded by this early cosmos, you would not have been able to see anything. The light was trapped in an endless pinball machine of collisions. This opaque fog persisted for an incredibly long time. The universe continued to expand, and as it stretched, the temperature steadily dropped. Then a specific moment arrived. 380,000 years. Give that number a moment to settle. 380,000 years after the beginning of time. At exactly this mark, the temperature of the expanding universe dropped just enough for a profound physical shift to occur. The cosmos cooled to approximately 3000 Kelvin. At this specific temperature, the chaotic, free-floating electrons finally slowed down enough to be captured by the protons. In a cosmic instant, the first true atoms of neutral hydrogen were formed. Because the electrons were suddenly locked away inside atoms, the fog instantly lifted. The charged particles that had been acting as a barrier simply vanished. For the very first time in the history of reality, the path was clear. The photons were suddenly free. In a singular flashbulb moment, an ocean of primordial light was released, rushing outward in every possible direction across the entirety of space. The universe suddenly became transparent. The light released in that exact moment is still travelling today. It has been flying through the vacuum of space for 13.8 billion years, moving at the absolute speed limit of the cosmos, on a direct, unbroken path toward the chair you are sitting in right now. When we look up with our telescopes, we capture this exact light. Because looking far away is looking back in time, when we look deep enough into the dark, we eventually see the exact moment that the fog cleared. We see the flash of the universe becoming transparent. We cannot see past it, because before that moment there was no free light to see. The plasma fog acts as an absolute physical barrier to our vision. It is an edge in time, but the light that is arriving here tonight does not look like the searing, blinding flash of a hot early universe. It has changed. Because space has been actively expanding for the entire 13.8 billion years that this light has been in transit, the fabric of the universe has stretched the light waves as they travelled. The photons that started their journey as incredibly high-energy, blistering radiation have been physically pulled apart by the expansion of the void. Their wavelengths have been stretched so far that they have shifted out of the visible spectrum entirely. They have been stretched into microwaves. This is why your eyes perceive the night sky as dark. If human eyes were capable of seeing microwave radiation, you would not see a dark sky dotted with stars. You would see a sky that is completely and fiercely glowing in every direction, day and night, with the brilliant, uniform light of creation. This ancient, stretched light has cooled dramatically over its long journey. When it was released, it was 3000 Kelvin. Today, as it washes over the Earth, it has cooled to a precise, freezing temperature. to 725 Kelvin. This is just a few degrees above absolute zero. It is roughly minus 270 degrees Celsius or minus 454 degrees Fahrenheit. To understand what this temperature truly means and how we experience the age and heat of this ancient light, we need to translate it into a space you are familiar with. Imagine an ordinary kitchen oven. Imagine turning the dial as high as it will go, letting the oven reach a searing, intense heat. The coils glow red, and the air inside is fiercely hot. Now imagine you turn the dial completely off. You unplug the oven from the wall, but you leave the heavy door tightly closed. You leave the kitchen, and you wait. You wait an entire week. If you were to come back a week later and open the heavy oven door, the searing heat would be completely gone. The air inside would feel absolutely ordinary and cold to your touch. Your human senses would tell you that the oven is dead, matching the temperature of the rest of the room. But if you placed an impossibly sensitive, highly calibrated scientific thermometer inside that oven, you would discover something incredible. The air inside the oven would be just a microscopic, almost imperceptible fraction of a degree warmer than the air in the hallway. The intense, violent fire of the past is gone, but it left behind a residual memory, a faint, lingering whisper of heat that has almost entirely faded away, but is undeniably still there. That is exactly what the cosmic microwave background is. It is the residual warmth of the Big Bang cooling over an unimaginably long stretch of time, fading into the freezing dark of the expanding cosmos. The searing heat of the early universe has been diluted into a faint, gentle whisper that is just 2.725 Kelvin above the absolute zero of perfectly empty space. For most of human history, we had absolutely no idea this faint warmth was there. We looked up at the stars and assumed the space between them was just a cold, silent void. But the universe was whispering to us the entire time. The discovery of this wall of light did not happen on purpose. It happened by accident, in an incredibly ordinary setting. In 1965, two radio astronomers named Arno Penzias and Robert Wilson were working at Bell Laboratories in New Jersey. They were using a massive, horn-shaped radio antenna, originally built for early satellite communications, to map radio signals from the Milky Way. They wanted to listen to the quiet hum of our local galaxy. To do that, they needed their equipment to be perfectly silent. But no matter where they pointed their giant antenna in the sky, they heard a persistent, irritating noise. It was a low, steady hiss of microwave interference. They tried everything to get rid of it. They checked their electrical connections, they cooled their instruments, they even climbed inside the massive metal horn with brooms and scrub brushes, thoroughly cleaning out the roosting pigeons and the white layers of pigeon droppings, assuming the birds were causing a thermal malfunction. But the noise did not go away. It did not fluctuate with the time of day. It did not change when the seasons shifted. It did not matter if they pointed the antenna at the dense heart of the Milky Way or at the emptiest patch of dark sky they could find. The faint, steady hiss was always there, coming from everywhere at once. They were not listening to pigeons, and they were not listening to a malfunction. They were listening to the oldest light in existence. They had accidentally tuned their radio antenna to the exact frequency of the cooling oven. They had detected the edge of time, measured directly. This discovery fundamentally changed our understanding of reality. It proved, without speculation, that the universe had a beginning. It proved that the cosmos was once incredibly hot and dense, and it proved that the void of space is not entirely empty. It is flooded, continuously, by the light of its own creation. Right now, as you rest quietly in your room, you cannot feel it. The walls of your home feel solid. The air is still. And everything is calm. But billions of these ancient microwave photons are harmlessly washing over you, passing through the walls and striking the surface of the Earth every single second. They are raining down from the sky, a constant invisible drizzle of history. You are sitting inside a 93 billion light-year bubble, and the absolute boundary of that bubble, the furthest thing that can possibly be known or seen, is a soft glowing wall of ancient plasma. But this wall of light is not the end of the story. It is merely the beginning of the deeper complication. Because when scientists finally launched satellites to map this wall of light in perfect detail, they found something deeply unsettling. The ancient light was perfectly smooth. The temperature was identical in every direction, balanced on an impossible, terrifying knife edge. The universe, according to the light, was too perfect. It shouldn't exist as it does. We have mapped the absolute boundary of our vision. We have measured the temperature of the cosmic microwave background, capturing the faint, residual whisper of creation that completely surrounds your home tonight. But when cosmologists actually looked at the data from this ancient wall of light, they found something deeply unsettling. The light told a story that did not make sense. The universe, according to the strict laws of physics and the data we have collected, is far too perfect. It shouldn't exist as it does. When you look around the room you are currently sitting in, you understand geometry intuitively. The walls meet at right angles. If you were to draw two perfectly parallel lines on your floor and extend them forever, they would never cross. If you were to draw a triangle on a piece of paper, the interior angles would add up to exactly 180 degrees. This is flat, ordinary, predictable space. But on a cosmic scale, space is not an empty, invisible box. It is a physical, flexible fabric. According to Albert Einstein's theory of general relativity, this fabric can bend, stretch, and warp in response to the mass and energy contained within it. Because space can bend, cosmologists use a specific critical number to describe the overall shape and curvature of reality itself. That number is called omega. Omega does not describe the shape of the Milky Way. It does not describe the shape of the massive superclusters drifting in the dark, or even the shape of our observable bubble in the conventional sense. Omega is a measurement of the global geometry of the cosmos. It compares the actual density of matter and energy in the universe to the exact critical density required to keep space perfectly balanced. To understand why this number is terrifying, we have to look at the three possible shapes the universe could have taken. If the universe contained too much matter, the immense collective gravity of trillions of galaxies would constantly pull the fabric of space inward. This would create a closed, positively curved universe. Think of it like the surface of a massive sphere. In this kind of universe, if you launched two photons of light on perfectly parallel paths, the physical curvature of space would eventually force their trajectories to bend inward, causing them to eventually cross. In a spherical universe, omega is greater than 1. If the universe contained too little matter, it would not have enough gravity to hold itself together against the outward push of cosmic expansion. Space would flare outward in every direction, curving away from itself like the sweeping shape of a saddle. In this open, negatively curved universe, those two parallel photons of light would slowly drift apart, diverging forever into the freezing dark. In a saddle-shaped universe, omega is less than 1. But there is a third option. If the exact amount of mass and energy in the cosmos is perfectly, immaculately balanced against the expanding force of space, the universe does not curve inward and it does not curve outward. It remains perfectly flat. In this scenario, parallel lines stay parallel for eternity. In this beautifully balanced reality, omega is exactly equal to 1. For most of human history, we did not know which of these 3 universes we lived inside. We could only guess. But then, we launched satellites to look at the wall of light. When the Planck satellite, the most precise cosmic measuring instrument humanity has ever constructed, mapped the tiny temperature fluctuations in the cosmic microwave background, it delivered a definitive, measured answer. The value of omega is 1.00, with a microscopic margin of error of just 0.005. The universe is flat. Not roughly flat. Not approximately flat. It is perfectly flat to within 0.5%, measured across a sphere 93 billion light-years in diameter. This is confirmed science. This is what the data says. You might hear that and feel a quiet sense of order. As you sit in your quiet room, feeling the steady pull of Earth's gravity, you might assume that a flat universe is simply the default state of things. You might assume that it is the natural resting point of a stable cosmos. But in the strict mathematical equations of general relativity, flatness is not a resting state. In cosmology, flatness is an unstable fixed point. To understand what this means, and why it threatens the existence of everything you know, we need to translate this abstract mathematics into a physical experience right there in your room. Imagine you are holding an ordinary wooden pencil. Imagine carefully standing that pencil up on your desk, perfectly vertical, balancing it entirely on its sharpened tip of graphite. You can let go, and with extraordinary care, for a fraction of a second, it stands perfectly straight. But you know exactly what is going to happen next. The balance is fundamentally unstable. The microscopic vibrations of the floorboards beneath your feet, a subtle draft of air moving through the room, or even the microscopic, uneven distribution of graphite at the tip will immediately disrupt the balance. The pencil will lean by a fraction of a millimeter. And the moment it begins to lean, gravity pulls it harder. The longer time passes, the further from vertical it gets. It falls faster and faster until it clatters flat against the wood of your desk. The geometry of our universe works the exact same way. If the value of omega had started out even slightly above 1, even by an imperceptible microscopic fraction, the collective gravity of the universe would have immediately begun to compound. Just like the falling pencil, the curve would have become more severe with every passing second. The expansion of space would have been dragged to a halt, and then violently reversed. All the matter in the universe would have rushed back inward, pulling every star, every planet, and every cloud of dust toward a single terrifying center. The cosmos would have collapsed into an infinitely dense, blindingly hot point known as the Big Crunch. The universe would have lived for a brief violent flash, perhaps a few 100,000 years, and then folded back into nothingness. If the value of omega had started out even slightly below 1, the opposite catastrophe would have unfolded. The expansion of space would have overpowered gravity instantly. Space would have stretched apart with runaway catastrophic speed. The primordial gases of the early universe would have been dispersed so rapidly that they could never clump together. Gravity would have been defeated before it ever had a chance to build a single galaxy. The universe would have instantly become a thinning, freezing, featureless void of dark emptiness. There would be no burning stars. There would be no planets. You would not be sitting in your chair right now, safely anchored to a solid world. The window between those two apocalyptic outcomes, between violent collapse and eternal dispersal, is extraordinarily narrow. For the universe to look as flat as we measure it today, after 13.8 billion years of continuous, stretching expansion, we have to calculate what the initial trajectory of the cosmos was. We have to wind the clock back to the very first instant of reality, to what physicists call the Planck time. This is an era 1043 seconds after the beginning, a window of time so unbelievably brief that expressing it in human terms is almost meaningless. At that exact initial moment, the value of omega had to equal 1 to an impossible degree of precision. It had to be precise to 1 part in 1062. Give that number the room it demands. 1 part in 1062. To understand what that means, try to imagine writing it down. It is a 1, preceded by a decimal point, and 61 zeros. If you were to sit at your desk right now and write out every single zero by hand, your ink would run dry several times over before you could fully capture the sheer scale of the denominator. It is a level of exactness that completely defies human comprehension. Imagine trying to win the lottery. The odds of winning a massive national jackpot are roughly 1 in 300 million. It is incredibly unlikely, but it happens. Now, imagine buying a single ticket and winning that exact same lottery. Then, imagine waking up the next week, buying another single ticket, and winning it again. Now, imagine doing that exact same thing, winning the grand prize 17 times in a row without a single failure. The mathematical probability of that happening is still vastly more likely than the universe blindly landing on a value of omega precise to 1 part in 1062. If the initial trajectory of our universe had differed from a perfect one by even a single unit in that 60-second decimal place, the cosmos would have destroyed itself. It would have dispersed into freezing gas, or crushed itself into a singularity long before a single star had the chance to cast light into the dark. This is not speculation. This is an inescapable mathematical reality confirmed by multiple independent teams of physicists. Think about the quiet stability of your surroundings right now. The floor beneath you feels solid. The air in your room is calm. The Earth orbits the Sun with reliable, clockwork precision, and the Sun drifts steadily through the Milky Way. You exist in a reality that feels permanent, safe, and deeply structured. But the physics underlying your room, your house, and the night sky above your roof are built on an unstable fixed point. You are living inside a system that, statistically speaking, had absolutely no right to survive its first second. Cosmologists call this the flatness problem. Calling it a problem is a remarkably polite understatement. It is an existential paradox. It is the sudden chilling realization that the cosmos is balanced on a knife edge so sharp that it challenges our basic understanding of reality. In physics, when you encounter a number this finely tuned, you cannot simply shrug your shoulders and assume we just got incredibly lucky. You cannot assume that out of all the effectively infinite range of values that omega could have taken, the universe just happened to blindly stumble upon the exact, singular fraction that would allow for the existence of stars, planets, and human life. To accept that would be to abandon science entirely. In physics, extreme fine-tuning requires a physical mechanism. It requires an explanation. There had to be something that forced the universe into this impossible balance. Something that grabbed the chaotic, wildly curving fabric of early space itself, overpowered its initial geometry, and ironed it completely flat. Whatever this physical mechanism was, it had to act instantly. It had to operate with a violence and a scale that defies the ordinary laws of cosmic expansion. And it had to happen everywhere, all at once, before the universe had even lived for a fraction of a heartbeat. As you sit in your chair, surrounded by the ordinary stillness of the evening, you are breathing air and resting on matter that only exists because of this ancient invisible calibration. The night sky is not a passive, peaceful canvas. It is the surviving remnant of an unimaginably precise, brutally forceful cosmic event. We are not just floating in a vast, empty void. We are balancing on the tip of a pencil. And the fact that we have not fallen over means that something in the deep past aggressively intervened. The perfectly smooth, mathematically flat wall of light that surrounds us is hiding a violent history. To solve the terrifying precision of the flatness problem, the universe had to undergo a process so extreme that it permanently fractured our reality. It solved the problem of our existence, but at a massive permanent cost, it walled us off from the vast majority of the cosmos forever. Right now, the exact geometry of the room you are sitting in is the surviving remnant of the most violent event in the history of physics. You cannot feel the violence. The floor beneath your feet is perfectly stable. The walls of your room meet at crisp, predictable right angles. If you were to slide a glass across your table, it would move in a straight line. The space around you feels calm, empty, and entirely passive. It feels like a quiet, empty container that simply allows things to exist inside it. But this local calm is a heavily engineered illusion. As we established, the universe had absolutely no right to be this flat. The mathematical knife edge required to prevent the cosmos from immediately collapsing into a big crunch or violently tearing itself apart into a freezing void is so impossibly precise that it defies all logic. The universe could not have simply stumbled upon a geometry accurate to 1 part in 1062 by pure chance. In physics, when a system is balanced that perfectly, it means something forced it into balance. It means a mechanism intervened. For decades, the standard model of the Big Bang was incomplete. It could successfully describe a universe that was expanding, cooling, and forming stars, but it could not explain how that universe survived its own birth. It could not explain the impossible flatness, and it could not explain why the ancient wall of light surrounding us, the cosmic microwave background, is the exact same temperature in every possible direction. Then, cosmologists proposed a solution. It is a solution that perfectly balances the equations of reality, but it requires accepting a physical event so extreme that it permanently fractured the cosmos. This mechanism is called cosmic inflation. This is confirmed science. It is the accepted foundation of modern cosmology, supported by multiple independent teams and written into the peer-reviewed literature. It is not a gentle process. It is not the slow, steady expansion of space that is currently carrying distant galaxies away from us tonight. Cosmic inflation is a highly specific, terrifyingly brief period in the very early universe where space itself went rogue. To understand what happened, we have to look back to a time long before the first atoms even existed. We have to wind the clock back to the absolute beginning, and then step forward by a fraction of a heartbeat. Inflation began at approximately 1036 seconds after the beginning of the universe. Give that number a moment to settle. 1036 seconds. This is a decimal point followed by 35 zeros and then a 1. It is a window of time so unimaginably brief that the human brain lacks the biological architecture to truly comprehend it. If you were to take a single second and divide it into 1,000,000,000,000 equal pieces, and then take just one of those microscopic pieces and divide it into 1,000,000,000,000 more pieces, you are still not even close to how incredibly brief this moment was. In that microscopic, almost non-existent sliver of time, the universe was dominated by a specific high-energy quantum field. This field acted like a powerful anti-gravity mechanism. Instead of pulling matter together, it exerted a massive repulsive negative pressure on the fabric of reality itself. And then, space exploded outward. It did not expand linearly, it expanded exponentially. It doubled in size, and then doubled again, and then doubled again, over and over, in rapid, uncontrollable succession. During this terrifying fraction of a second, the fabric of the universe grew by a factor of at least 1026. 1026. To understand the sheer violence of that multiplier, we need to translate it into a physical scale you can picture. Imagine holding a single microscopic atom of hydrogen in the palm of your hand. An atom is already invisible, sitting far beyond the threshold of human perception. Now, imagine that atom suddenly undergoing the exact same scale of inflationary expansion. In much less than a trillionth of a second, that single invisible atom would instantly inflate to become larger than the entire 93 billion light-year observable universe we live in today. That is what happened to the fabric of space. You might immediately wonder how this is possible. You might remember the strict, unbreakable rule we established earlier: nothing can travel faster than the speed of light. But this is where the physics of the cosmos requires a very careful distinction. The speed of light is the absolute speed limit for any object moving through space. But space itself is not an object. The vacuum of the cosmos is not bound by the rules of ordinary movement. Space itself can stretch, warp, and expand at any speed it dictates. During inflation, the fabric of reality expanded outward at speeds billions of times faster than light. This brutal exponential stretching is exactly what solved the flatness problem. To see how, imagine that you are holding a completely deflated, highly wrinkled balloon. If you were to look closely at the rubber, you would see deep curves, sharp ridges, and chaotic, unpredictable geometry. If you imagine that wrinkled surface as the initial chaotic state of the early universe, it is highly curved and entirely unstable. Now imagine attaching that balloon to a high-pressure air tank and instantly inflating it until it is the size of the planet Earth. If you were to then stand on the surface of that Earth-sized balloon, look down at your feet, and try to measure the curvature of the rubber beneath you, what would you find? From your localized, incredibly small vantage point, the rubber would appear perfectly, immaculately flat. The rapid, overwhelming expansion did not erase the curves, it simply stretched them out to such an enormous scale that they became mathematically undetectable. Inflation grabbed the wildly curving, unstable fabric of the early universe and stretched it with such overwhelming force that any initial curvature was completely ironed out. It drove the geometry of our reality to that perfect, balanced, fixed point. The space in your room is flat today because it was violently stretched tight billions of years ago. This is what the data says. When we measure the cosmic microwave background, we are looking at the surviving fingerprint of this exact stretching event. But in physics, a solution of this magnitude never comes for free. Every cosmic solution has a massive permanent cost. By stretching the universe to solve the flatness problem, inflation did something else. It permanently altered the boundaries of what we are allowed to know. Before inflation began, the region of space that would eventually become our entire 93 billion light-year observable universe was unfathomably small. Because it was so small, all the matter and energy inside it was packed tightly together. Everything was in direct, physical contact. The primordial plasma could easily mix, exchanging heat and information, ensuring that the entire tiny region reached the exact same temperature. This is why the cosmic microwave background looks identical in every direction today. It is perfectly uniform because originally it was all touching. It was a single, deeply connected neighborhood. But then the violent stretching began. Inflation ripped this intimately connected family of matter apart. Space expanded so fast and so violently that it took regions of space that were once right next to each other and pushed them away at billions of times the speed of light. It pushed them so far away that light itself can no longer bridge the gap. This is the deeper, darker layer of the cosmos. The mechanism that made our existence possible, the very stretching that flattened the universe and allowed stars and planets to form, is the exact same mechanism that walled us off from the vast majority of reality. When inflation finally stopped, and the universe settled into the calmer, slower expansion we experience today, the damage was already done. The overwhelming majority of the universe had been pushed permanently beyond our visual horizon. The 2 trillion galaxies that we can currently see, the 93 billion light-year bubble that surrounds your exact position, is not the entire universe. It is not even close. It is merely the tiny localized fragment of space that did not get pushed away too fast. Based on the measurements of flatness we have taken, cosmologists have calculated the absolute minimum size of the true, unobservable universe that inflation created. The math dictates that the actual universe must have a radius at least 251 times larger than the bubble we live inside. If you convert that radius into volume, the numbers become staggering. Inflation guarantees that there is at least 15 million times more volume outside our observable universe than there is inside it. 15 million observable universes, packed full of matter. This translates to roughly 32 sextillion galaxies. That is a 32 followed by 21 zeros. All of these galaxies are physically real. They were formed by the exact same physics that formed the Milky Way. They are composed of the same elements, governed by the same gravity, and illuminated by the same types of burning stars. There are gas giants with massive storms, cold moons orbiting in the dark, and perhaps distant worlds completely unaware of our existence. They were originally born in the same microscopic patch of space that we were. They are our cosmic siblings. But because of the violence of inflation, they have been thrown so far out into the deep dark that their light will never ever reach us. No matter how powerful our telescopes become, and no matter how long the human race survives to look upward, those galaxies will remain completely and permanently invisible. They are out there right now, existing in total silence, hidden behind a mathematical wall that we can never cross. As you sit in your room, feeling the quiet stability of the space around you, you are sitting inside a microscopic fragment of a much larger whole. The universe is not a museum waiting to be explored. It is a fragmented, shattered landscape. The stillness you feel is real, but it was paid for. The physics that allowed you to exist also ensured that you will spend your entire life locked inside a tiny, brilliantly lit viewing room, while the vast, overwhelming majority of creation continues on in the dark, completely beyond your reach. You are a small thing inside an enormous hidden structure, and the mystery only deepens when we realize that the universe outside our bubble is actively pulling on the things inside it. Right now, as you are sitting in your room, you feel perfectly still. The floor beneath your feet is solid, the air around you is calm. If you look at the objects resting on your desk or the shadows cast against your walls, nothing is moving. Your biological senses are telling you that you are at rest. You are anchored to a safe, quiet, and stationary point in space, but you already know that this stillness is a local illusion. You know that the Earth is actively rotating, spinning you through the dark. You know that the Earth is orbiting the Sun, and that the Sun is currently dragging our entire solar system through the swirling, densely packed arms of the Milky Way galaxy. All of this motion is happening right now, at terrifying speeds, but because everything around you is moving together, you do not feel a thing. You feel as though you are sitting in a quiet room. However, there is another layer of motion happening to you right now. It is a motion so massive and so profoundly deeply buried in the structure of reality that scientists did not even realize it was happening until very recently. We are not just drifting through our local galactic neighborhood. Our entire region of the cosmos is being dragged. We are caught in a current. And the speed of this current is staggering. Our galaxy, along with hundreds of massive galaxy clusters surrounding us, is currently streaming across the universe at over 2 million miles per hour. 2 million miles per hour. Give that number its own space. To understand the sheer violence of that speed, we must translate it into the reality of your immediate surroundings. In the time it took you to hear that sentence, you, your home, the Earth, and the entire Milky Way galaxy just physically moved more than 1,000 miles through the cosmic vacuum. By the time this minute is over, you will have travelled over 30,000 miles. You cannot feel the wind of this movement. Your coffee still sits perfectly level in its cup. But you are inside this problem right now. You are physically hurtling through space in a very specific direction. This phenomenon is called dark flow. This is confirmed science. This is not speculation. This is measured directly by some of the most sophisticated instruments humanity has ever built. In 2008, a team of astrophysicists led by Alexander Kashlinsky at NASA's Goddard Space Flight Center was studying some of the largest, most violent structures in the cosmos. They were looking at giant galaxy clusters. These clusters are not just loose collections of stars. They are massive, gravitationally bound neighborhoods containing thousands of individual galaxies, all swimming in an ocean of superheated gas that burns so intensely it continuously emits X-ray radiation. Kashlinsky and his team wanted to map how these massive galaxy clusters were moving through space. But measuring the speed of an object that is billions of light years away is incredibly difficult. To solve this, they used the ancient wall of light we explored earlier. They used the cosmic microwave background. Remember that the cosmic microwave background is the residual uniform heat left over from the Big Bang. It completely surrounds us, acting as a glowing backdrop to the entire universe. The researchers realized that as these massive, superheated galaxy clusters drift through the freezing void of space, they have to physically pass in front of that ancient wall of light. To understand how scientists used this to measure speed, imagine a perfectly calm, brightly glowing screen sitting far away in the dark. Now imagine someone walks between you and the glowing screen, carrying a sheet of incredibly hot, rippling glass. As the light from the screen passes through the hot glass, the energy of the light is physically altered. The temperature of the light shifts slightly before it reaches your eyes. If you possess an impossibly sensitive, highly calibrated instrument, you can measure that microscopic shift in temperature. And by analysing exactly how the light was altered, you can calculate precisely how fast the sheet of glass was moving when it crossed your path. This is an exact analogy for what happens in the deep universe. It is a phenomenon known as the Sunyaev-Zeldovich effect. The superheated X-ray gas inside the moving galaxy clusters physically collides with the ancient microwave photons of the cosmic background radiation. The collision scatters the photons, shifting their temperature by a microscopic fraction of a degree. When the NASA team examined the data from the Wilkinson Microwave Anisotropy probe, they analysed the temperature shifts across hundreds of galaxy clusters, spanning distances of up to 6 billion light-years away. They mapped the movement of a massive, staggering chunk of our observable universe. What they expected to find was random motion. According to the standard models of cosmology, after the violent exponential stretching of cosmic inflation, matter should have been distributed fairly evenly. the gravitational pull of the universe should be roughly the same in every direction. Galaxies should drift, certainly, but they should drift randomly, pulled equally by the web of matter surrounding them. But the data told a completely different, deeply unsettling story. The motion was not random. The clusters were not drifting aimlessly. They were perfectly aligned. Hundreds of massive galaxy clusters, stretching halfway across the observable universe, were all flowing like a river in the exact same direction. They were streaming at 2 million miles per hour toward a very specific patch of sky, located between the constellations of Centaurus and Vela. When cosmologists pointed their most powerful telescopes toward that exact patch of sky to see what was pulling them, they found something terrifying. They found absolutely nothing. There is no massive supercluster of galaxies sitting in that region of space. There is no anomalous concentration of dark matter. There is no physical structure inside our 93 billion light-year observable bubble that possesses enough gravitational mass to drag hundreds of galaxy clusters across billions of light-years of space at 2 million miles per hour. The mass required to exert that kind of gravitational dominance over our reality simply does not exist within our visible universe. And yet, the pull is undeniably real. The data shows it. You are moving toward it right now. In physics, when you witness an effect but cannot see the cause, it means the cause is hidden behind a boundary. The mechanism pulling us is not invisible because it is made of dark matter, and it is not invisible because our telescopes are too weak. It is invisible because it is sitting entirely outside the Hubble volume. It is sitting completely beyond the cosmic event horizon. This is the deeper, darker layer of the cosmos. This is where the true, terrifying scale of cosmic inflation finally reveals itself. As we established, inflation violently stretched the fabric of the early universe, taking regions of space that were once right next to each other and pushing them billions of times faster than the speed of light. It pushed the vast majority of creation permanently out of our view. It walled us off. But gravity does not care about the wall of light. Gravity is the curvature of space-time itself. Before inflation ripped the universe apart, the matter that would eventually become our observable universe was in direct physical contact with the matter that would eventually be pushed outside of it. The gravitational relationship between our local space and the space outside of it was already established before the violent stretching began. Inflation pushed the physical structures away faster than light can travel, meaning their image will never ever reach our eyes. But their gravitational anchor remains. There are massive, unfathomably large structures lurking just outside the boundary of our observable bubble. They are sitting in the dark, permanent shadows from the outside, and they are so unimaginably massive that their gravitational field is reaching through the boundary of the observable universe and dragging our entire cosmic neighborhood toward them. You might feel a sudden, quiet unease at this invisibility. It is one thing to accept that the universe is vast and empty. It is another thing entirely to realize that the universe is not empty, and that massive, unseen entities are actively dictating the physical movement of the chair you are sitting in right now. Think about the scale required to accomplish this. To drag a region of space 6 billion light-years across at speeds of 2 million miles per hour, the structure outside our observable bubble cannot just be another galaxy. It cannot even be a normal supercluster of galaxies. Scientists are forced to confront the reality that the structure of the infinite universe beyond our point of view is not uniform. The universe outside our bubble is not just a smooth, even repetition of what we see inside it. The structures pulling us could literally be anything. They could be accumulations of matter and energy, on a scale so utterly monstrous that they defy the standard laws of cosmic evolution. They could be regions of space where matter clumped together with a density that never occurred inside our local bubble. They might even be bizarre, monumental fault lines in the geometry of space-time itself, conducting gravitational forces from other regions of reality. Whatever they are permanently hidden from us. We will never see them. The accelerating expansion of space guarantees that the light from those massive architectures will forever be trapped behind the cosmic horizon. We can only feel their shadow. We can only experience their weight. You are a participant in this massive, invisible event. As you rest in your room, listening to the quiet of the night, you are caught in a cosmic tide. You are part of a river of matter, billions of light years long, silently rushing through the dark toward a destination you are not allowed to see. The universe is not a static museum waiting patiently for us to explore it. It is an active, dynamic, and deeply interconnected landscape. Even though inflation fractured our reality and walled us off from our cosmic siblings, the universe refuses to be completely severed. The outside still pulls at the inside. But this realization that invisible structures can permanently alter our physical reality without ever exchanging light or direct information with us, forces us to confront an even deeper, more profound complication. If something exists outside of our observable bubble, pulling at us from the dark, but it can never be seen, never be touched, and never truly interact with us again, does it actually exist relative to us at all? If a piece of the universe crosses the cosmic event horizon, physics suggests that reality itself begins to fray. The physical deletion of space creates a paradox so unsettling that it bridges the gap between the infinite scale of the cosmos and the microscopic world of quantum mechanics. The boundaries of what is real are beginning to blur. Right now you are surrounded by a deeply comforting assumption. As you rest in your room, feeling the steady pull of gravity holding you in your chair or your bed, you naturally assume that the world outside your door is physically real. You assume that the street outside your building exists, even when you are not looking at it. You assume that the moon is still orbiting the Earth, even if the curtains are drawn and the sky is completely hidden from your view. You believe these things exist because they belong to a shared unified reality. You are connected to them by an invisible, unbreakable chain of cause and effect. If a car drives down the street, its tires push against the pavement, creating sound waves that travel through the air, vibrate the glass of your window, and eventually reach your ear. The cause creates an effect. If the moon shifts in its orbit, its gravitational pull subtly alters the tides of the oceans, changing the tension of the Earth's crust beneath your feet. This continuous exchange of physical signals is what holds the universe together. It is a concept known as causality. Causality is the strict, unwavering rule that an event in one place can cause an effect in another place, as long as a signal has enough time to travel between them. Causality is the literal glue of reality. It is the reason the universe makes sense. But out in the deep dark, at the extreme edges of our expanding cosmos, this fundamental rule is quietly breaking down. Earlier we established that the universe is actively expanding, and that this expansion is accelerating. We established that there is a mathematical boundary drawn around us, called the cosmic event horizon. This horizon currently sits about 16.6 billion light-years away. 16.6 billion light-years. Give that number a moment to settle in your mind. Any galaxy sitting beyond that specific line is being pushed away from us so incredibly fast that no signal it emits right now will ever be able to reach us. Not tomorrow, not in 1 trillion years, not ever. The expansion of space will forever outpace the speed of light. When a galaxy physically crosses that horizon, the chain of cause and effect is permanently severed. Because no physical signal can ever bridge the widening gap, nothing that happens in that galaxy can ever affect you, and nothing you do can ever affect them. The interaction stops completely. This creates a deeply unsettling question. It is a question that sits at the very frontier of modern physics, bridging the massive scale of cosmology with the microscopic rules of quantum mechanics. If a region of space crosses the cosmic event horizon and can never interact with us again, does it still exist relative to us? To answer this, we must look at how physics defines existence. In the realm of quantum mechanics, reality is not built out of solid objects. It is built out of information. When physicists talk about information, they do not mean words in a book or data on a computer screen. Quantum information is the exact physical state of every single particle in a system. It is the precise mass of a proton. It is the exact spin of an electron. It is the specific trajectory of a photon of light. Information is the raw, fundamental code of reality. And according to the strictest laws of quantum mechanics, information can never be destroyed. To understand this complex quantum rule, we must translate it into a localized domestic experience. Imagine you are holding a handwritten letter in your quiet room. The letter contains specific information. If you take a match and burn the letter until it is nothing but smoke and grey ash, your human common sense tells you that the information is gone. The words are destroyed. But quantum physics disagrees. In physics, the information is not destroyed. It is simply scrambled. The exact state of the paper was transferred into the heat of the fire, the composition of the smoke filling the room, and the microscopic structure of the ash resting on your desk. If you possessed a theoretical supercomputer of unimaginable power, you could track every single atom of smoke and every single particle of ash, reverse the chemical reaction, and perfectly reconstruct the letter. The information still exists within your room. It is just remarkably difficult to read. This is the foundational rule of reality. Information must be preserved. It must exist somewhere in the causal universe. But what happens when we apply this strict rule to the expanding cosmos? Imagine a massive, swirling galaxy billions of light years away. That galaxy contains an ocean of physical information. It contains the spin of trillions of electrons, the mass of billions of burning stars, and the complex chemistry of massive storm systems on distant gas giants. All of that is quantum information. Now imagine that galaxy drifting across the cosmic event horizon. It slips past the mathematical line of no return. It enters a region of space expanding so rapidly that its light, its gravity, and its quantum states can never reach your chair again. It is fundamentally severed from your reality. If quantum information can never be exchanged, physics suggests that the space it occupies is no longer part of our physical universe. To make this epistemological paradox clearer, let us return to your home. Imagine there is a heavy steel safe sitting in the corner of your bedroom. Imagine you are told there is a specific arrangement of coins inside that safe. But you are also told that you can never open the door. You can never weigh the safe. You can never scan it, touch it, or listen to the sounds inside it. If it is physically impossible for any signal to ever leave the inside of the safe and reach your senses, does the specific arrangement of coins inside it actually exist relative to you? In quantum mechanics, the answer leans toward no. Reality is defined by interaction. If a system cannot interact with you, even in principle, its quantum state is entirely undefined from your perspective. It is entirely outside your reality. This is not speculation. This is an inescapable logical consequence of how quantum information behaves in an expanding universe. The cosmic event horizon is building a literal, impenetrable wall around our reality. It is not a wall made of stone or glass. It is a wall made of causality itself. But the paradox deepens. If the information of that distant galaxy cannot cross the horizon to reach us, and quantum mechanics forbids information from being completely destroyed, where does the information go? The answer lies in the thermodynamic reality of the horizon. We are used to thinking of the cosmic horizon as an imaginary line in space. We think of it like a border on a map, a concept invented by humans to measure distance. But in the mathematics of advanced cosmology, the horizon is not an imaginary line. It is a physical thing. The cosmic event horizon has physical properties. It possesses a measurable temperature. It contains a specific amount of entropy. It is a thermodynamic surface that interacts with the fabric of the universe. This realization was born from the study of black holes in the 1970s and 1990s. Physicists realized that when an object falls into a black hole, crossing its event horizon, the object is gone from our universe, but its information cannot be destroyed. Instead, the information of the falling object is permanently smeared across the two-dimensional surface of the black hole's boundary. This mind-bending mathematical discovery grew into one of the most profound theories in modern science. It is called the holographic principle. This is confirmed science. Multiple independent teams and the most rigorous mathematical frameworks in string theory support this principle. The holographic principle states that all the information required to perfectly describe a three-dimensional volume of space is actually encoded on the two-dimensional surface that bounds it. Think of an ordinary everyday hologram. You might have seen one printed on a credit card or a novelty sticker. When you look at the flat, two-dimensional piece of plastic, your eyes perceive a fully structured, three-dimensional image. The depth is an illusion. All the complex information required to build that 3D image is physically etched into the flat, 2D surface of the plastic. The universe appears to operate on the exact same logic. Volume and information do not scale together. Information scales with surface area. When we apply the holographic principle to the entire observable cosmos, the implications are staggering. We are living inside an expanding bubble of space. The absolute edge of this bubble is the cosmic event horizon. When that distant, swirling galaxy is pushed across the horizon by the accelerating expansion of dark energy, it does not just quietly vanish into the dark, it collides with the causal boundary of our reality. As the galaxy crosses the threshold, every single piece of quantum information it contains, every star, every planet, every swirling storm of gas, is flattened. The three-dimensional reality of that galaxy is stripped away, and its raw quantum data is perfectly encoded onto the glowing, two-dimensional surface of our cosmic horizon. The boundary of our reality encodes the interior. The edge contains the information about everything that has slipped past it. This means that the horizon of the universe is not just a limit on what our telescopes can see. It is a hard, thermodynamic limit on what physically exists. You might feel a quiet unease at this realization. It is a profound and deeply isolating truth. As you sit in your room, the walls around you feel solid. The air feels three-dimensional. Your reality feels deep, immersive, and completely secure. But the fundamental physics of the cosmos suggest that our universe is functioning like a grand, intricate projection. The universe is actively editing our reality. Every passing second, space stretches further. Galaxies that were once part of our shared causal universe are dragged to the edge. They hit the invisible wall of causality, their physical forms are deleted from our reality, and their memory is smeared into a two-dimensional mathematical code on the perimeter of our bubble. The universe is quietly archiving its own history, locking it away on a surface we can never touch. This forces us to reevaluate our exact place in the cosmos. We are not explorers walking through an infinite static forest, free to observe every tree if we simply walk far enough. We are inhabitants of a shrinking causal island. The universe is actively deciding what is allowed to be real for you. If an object cannot send a photon to strike your eye, if it cannot exert a gravitational pull to subtly shift the earth beneath your feet, it is no longer permitted to exist in your physical reality. Causality has built a literal wall around your life, and the accelerating expansion of space is ensuring that this wall grows more isolating every single day. This is what the data says. This is established physics. There is a calm existential weight to this phenomenon. It does not demand fear, because you are perfectly insulated from the edges. Locally, in the quiet safety of your room, causality remains perfectly intact. The glass on your table remains solid. The floorboards beneath your feet remain stable. Your breathing is uninterrupted. But out there in the deep dark, the boundary of what can be known is functioning as a physical eraser. The universe is not an endless container of objects. It is a strictly managed web of information. And right now, as you rest in the dark, the universe is quietly pruning that web, severing the threads, and permanently archiving the lost galaxies on the holographic edge of our reality. We are small things, trapped inside a bubble, surrounded by a glowing, two-dimensional wall of lost information. And as we are about to discover, the mathematics that governs the space beyond this wall demands an even stranger possibility. Because if the information of our reality stops at the horizon, what rules govern the infinite space that was pushed outside? We have reached the absolute physical limit of our reality. The cosmic event horizon has drawn a strict thermodynamic wall around your life, permanently deleting the physical forms of distant galaxies and archiving their quantum information on a glowing, two-dimensional edge. If you rely entirely on your eyes, or even the most powerful telescopes humanity will ever construct, the story ends at that wall. But physics is not limited to what we can see. When observation hits a physical boundary, we do not simply give up. We use the laws of physics that we have rigorously tested inside our bubble, and we follow their mathematical consequences to see what they demand exists on the outside. When we do this, the mathematics provides a partial resolution to the mystery of our isolated existence. But the answer it provides is so unimaginably vast that it fundamentally redefines what the word universe actually means. To understand what is happening outside our bubble, we must return to the mechanism that solved the terrifying precision of the flatness problem. We must return to cosmic inflation. Earlier we established that in the first microscopic fraction of a second of existence, the fabric of space was dominated by a specific high-energy quantum field. This field exerted a massive negative pressure, causing space to expand exponentially. It stretched our reality completely flat, solving the impossible knife-edge geometry of the cosmos, but it permanently walled us off from the vast majority of creation. But how did this violent stretching actually stop? In the models that best fit our current data, physicists describe this high-energy field using a very simple analogy. Think of a ball sitting high on a gently sloping hill. The height of the ball represents the energy of the field. While the ball is high on the hill, the energy is immense, and space expands at an uncontrollable, exponential rate. As time ticks by, the ball slowly rolls downward. When the ball finally reaches the bottom of the hill, the energy drops to its lowest point. The exponential stretching completely stops. The remaining energy is violently dumped into the vacuum of space, creating a searing hot soup of ordinary matter and radiation. This specific moment, the moment the ball hit the bottom of the hill and the stretching stopped, is what we call the Big Bang. The Big Bang was not the beginning of everything. It was merely the localized moment when inflation finally ended in our specific cosmic neighborhood. If the universe were perfectly smooth, the ball would have rolled down the hill at the exact same pace everywhere, and inflation would have ended everywhere at the exact same time. But quantum mechanics forbids anything from being perfectly smooth. In the microscopic quantum world, there is a constant, unavoidable jitter. As the field slowly rolled down the hill, random quantum fluctuations were constantly nudging it. Most of the time, these tiny nudges did nothing to stop the downward roll. But because quantum mechanics is based on probability, physicists realized that occasionally, by pure random chance, a severe quantum fluctuation would kick the ball backward, pushing it back up the hill. In the regions of space where the ball was kicked backward, the energy of the field stayed high. In those specific regions, the exponential stretching did not stop. It continued. This creates a staggering mathematical paradox. The regions of space where the ball rolled to the bottom stopped inflating. They became quiet, calm, ordinary space, filled with matter and eventually stars. But the regions where the ball was kicked back up the hill continued to expand exponentially. Because exponential expansion multiplies volume at terrifying speeds, the inflating regions of space were growing vastly faster than the quiet regions could ever form. For every pocket of space that successfully stopped inflating, the space around it expanded 1 billion times over, creating an infinite amount of new space where quantum fluctuations could trigger yet again. This means that once cosmic inflation begins, the mathematics demands that it never completely stops. This phenomenon is called eternal inflation. This is confirmed science. This is not science fiction. This is what the data says. The exact same mathematical framework that perfectly predicts the temperature fluctuations in the cosmic microwave background, the measurements confirmed by the Planck satellite to within a fraction of a percent, inescapably predicts that inflation is still happening right now. It is happening completely outside our causal horizon, far beyond the wall of light, in a grand, overarching background of rapidly stretching space. Within this violently expanding background, regions of space are constantly successfully rolling to the bottom of the hill. Every time that happens, a new Big Bang occurs, and a new pocket of calm, structured space is carved out of the chaos. Imagine a vast, continuously expanding block of Swiss cheese. The solid cheese is the rapidly inflating, high-energy background space. The holes in the cheese are the quiet, stable pockets where inflation has stopped. Our entire 93 billion light-year observable universe, containing all 2 trillion of our galaxies, all of our stars, and every world we will ever map, is located entirely inside just one of those microscopic holes. We are living inside a single bubble, and out there in the deep dark, separated from us by an ever-expanding ocean of inflating space, there are other bubbles. There is an infinite sea of pocket universes, constantly appearing and evolving, completely disconnected from one another. Because the space between the bubbles is still inflating exponentially, it is expanding far faster than the speed of light. No signal, no spacecraft, and no beam of radiation can ever cross the gulf between one bubble and the next. They are permanently, structurally isolated. This is the multiverse. It was not invented because physicists wanted a grand, fantastical story. It was not added for drama. It is a mandatory, logical consequence of the equations that perfectly explain why the room you are sitting in is flat. If we accept the math that explains our own existence, we must accept the sheer scale of the structure that birthed us. But the realization deepens. If there are countless other bubble universes out there, quietly forming in the eternal dark, what do they look like? According to string theory, one of the leading mathematical frameworks for understanding the fundamental building blocks of reality, the laws of physics are not fixed. The specific mass of an electron, the exact strength of gravity, and the precise behavior of light are determined by how the fundamental dimensions of space are folded together at the microscopic level. When a bubble universe forms and its local Big Bang occurs, the energy of inflation cools and settles into a specific configuration. It settles into a vacuum state. The mathematics of string theory suggests that there is not just one possible vacuum state. There is a vast landscape of possibilities. The number of possible mathematical configurations for a universe is currently estimated to be around 10,500. Give that number a moment to settle in your mind. 10,500. To understand the sheer crushing scale of that number, remember that the total number of physical atoms in our entire observable universe, every single atom inside all 2 trillion galaxies, is estimated to be roughly 1080. The number of possible configurations for the laws of physics dwarfs the total number of atoms in our reality by a margin so immense that human language simply breaks down. In the eternal inflation framework, every time a new bubble universe forms, it randomly drops into one of these 10,500 possible states. This means that the bubble universes outside of ours do not just contain different galaxies. They contain entirely different physics. There are bubbles where gravity is billions of times stronger, instantly crushing any matter into black holes the moment the universe is born. There are bubbles where the electromagnetic force is slightly weaker, meaning atoms can never properly bind together, resulting in an eternal featureless soup of drifting particles. There are bubbles with no light, bubbles with different dimensions of time, and bubbles that tear themselves apart in a fraction of a second. Most of these pocket universes are entirely dead. They are fundamentally incompatible with complexity, chemistry, or life. But because eternal inflation never stops, the number of bubbles it creates is infinite. And this is where the calm, quiet reality of an infinite structure forces a deeply strange conclusion. If you have an infinite number of bubbles and only a finite, even if incomprehensibly large, number of ways to arrange the laws of physics, then eventually patterns must repeat. Somewhere out there, spanning across an unbridgeable distance of eternally expanding space, the mathematical configuration of our specific bubble has occurred again. Given an infinite expanse, there is a bubble universe where gravity operates exactly as it does here, where carbon forms in the exact same way, where an identical Milky Way galaxy spun into existence and an identical Earth formed in its quiet outer spiral arm. Because infinite variation guarantees repetition, the math insists that there is another version of you, sitting in an identical room, resting in an identical chair, looking at an identical screen. This is not a certainty we can ever touch, but it is an allowance physics strictly provides. You are completely safe from this scale. You are insulated. You will never meet these other iterations of reality, and they will never meet you. You are permanently bound to your specific bubble, anchored to the present moment, listening to the quiet sounds of your own room. The multiverse mathematics does not erase your local reality. It merely provides a partial resolution to the paradox of our existence. We are balanced on an impossible knife edge of physics. Not because the universe was designed specifically for us, but because out of the infinite foam of cosmic bubbles, we simply woke up in the specific one where waking up was mathematically allowed. We finally have a framework to understand what lies beyond the observable wall. We know, mathematically, what the structure of the grand cosmos looks like, but as we are about to discover, knowing the math does not save us from the physical reality of our own specific bubble. Because while eternal inflation is building an infinite sea of universes out in the dark energy inside our own bubble is actively, relentlessly erasing the sky above your roof. Right now, the night sky above your roof feels like a permanent fixture. When you turn off your lights and look out the window, the darkness is dotted with the steady, quiet glow of stars. You naturally assume that if you were to stand in this exact spot 1 billion years from now, the view would be largely the same. You assume the universe is a stable, enduring museum of light, and that humanity simply needs to build larger telescopes to see further into its endless halls. But the museum is closing. Earlier, we established the sheer scale of the reality you are currently sitting inside. We mapped the boundaries of your personal 93 billion light-year bubble. We confirmed that inside this specific sphere of visibility, there is an unfathomable amount of structure. 2 trillion galaxies. Give that number a moment to settle in your mind. 2 trillion massive swirling oceans of stars, dust and planets, all currently accessible to our telescopes. It feels like an overwhelming abundance of information. It feels like a permanent inheritance. But the physics of the cosmos guarantees that this abundance is temporary. You are not looking at a static landscape. You are looking through a window that is actively, continuously shrinking. To understand why the universe is hiding itself, we have to look at the invisible force that is currently dominating the fabric of space. For most of the 20th century, cosmologists assumed that the expansion of the universe was slowing down. It made perfect logical sense. The universe was filled with matter, and matter possesses gravity. Every single star, every galaxy, and every massive cloud of dust exerts a gravitational pull on everything else. Physicists assumed that this collective universal gravity was acting like the brakes on a car, slowly dragging the expansion of the Big Bang to a halt. But in the late 1990s, when astronomers measured the light from distant dying stars to see exactly how fast the universe was slowing down, they found something deeply unsettling. The universe was not slowing down at all. It was speeding up. The expansion of space was accelerating. This is confirmed science. This is established by direct measurements of supernovae across the deep cosmos. Something invisible, silent, and overwhelmingly powerful is pushing the universe apart. Cosmologists call this phenomenon dark energy. The name is simply a placeholder. It is a label for an effect we can measure but cannot fully explain. We do not know exactly what dark energy is, but we know exactly what it does. It exerts a negative pressure on the fabric of reality. It does not clump together like gravity. It does not form structures. It is a smooth, even, relentless outward push that exists everywhere, including the empty space in the room around you right now. And it is the dominant force in reality. Currently, dark energy makes up approximately 68% of the total energy content of the cosmos. 68%. More than 2/3 of the universe is made of a repulsive force that actively pushes galaxies apart. And because dark energy is a property of space itself, as space expands, there is more space. As there is more space, there is more dark energy. The outward push is compounding. You cannot feel it. The gravity of the Earth easily overpowers dark energy, keeping your feet firmly on the floor. The gravity of the Sun keeps the Earth in a steady orbit. Even the gravity of our local group of galaxies is strong enough to hold our immediate cosmic neighbours together. Locally, you are entirely safe. But out in the deep dark, in the vast voids between superclusters, gravity is too weak to fight back. In those massive, empty spaces, dark energy is winning decisively. It is stretching the fabric of the universe faster and faster. This acceleration has a profound physical consequence for the future of your night sky. Because space is stretching faster than the speed of light, distant galaxies are actively being carried away from us. When a galaxy is pushed far enough, the space between us and that galaxy is expanding so rapidly that the light it emits right now will never be able to cross the widening gulf. This means that the observable universe, the collection of things we can actually see and interact with, is functionally emptying out. The erasure of the cosmos is not a violent event. The galaxies are not exploding, they are not being crushed into darkness. If you were standing on a planet inside one of those distant galaxies, you would feel absolutely nothing. Your sun would still shine. Your gravity would still hold you to the ground. Instead, the erasure is a slow, quiet fading. As a distant galaxy is carried away by the accelerating expansion of space, the light it sends toward us is physically stretched. Imagine drawing a tight undulating wave on a rubber band and then pulling the ends of the rubber band apart. The wave stretches out. The peaks and troughs grow further apart. This is exactly what happens to light travelling through expanding space. The physical wavelength of the light is stretched. As it stretches, its colour shifts toward the red end of the spectrum. This is called cosmological redshift. As the expansion accelerates, the stretching becomes more extreme. The light from that distant galaxy is stretched past the visible spectrum entirely. It is stretched into infrared. Then it is stretched into microwaves. Then into long, slow radio waves. The energy of the light drops lower and lower, becoming fainter and weaker with every passing million years. Eventually, the wavelength is stretched so thin, and the energy drops so low that the light becomes completely undetectable. The galaxy simply fades into the freezing dark. It does not disappear from reality, but it completely and permanently disappears from our reality. The causal bridge is burned. Right now there are galaxies whose light is still reaching us, but whose physical bodies have already crossed the mathematical point of no return. We are looking at their ancient ghosts. The light they are emitting tonight will never arrive. If we fast forward the clock of the universe, the consequences of this quiet erasure become stark. Imagine sitting in your exact location, but 100 billion years in the future. 100 billion years. That is more than 7 times the current age of the entire universe. It is an expanse of time so vast that the human mind cannot truly hold it. By that distant epoch, the relentless push of dark energy will have reshaped the night sky completely. Our Milky Way galaxy will have long since collided and merged with our nearest large neighbour, the Andromeda galaxy, forming a single, massive, elliptical swirl of aging stars. The smaller dwarf galaxies in our local group will have been pulled in and consumed. We will exist inside one massive localized island of stars. But if an astronomer in that distant future looks past the edge of our merged galaxy, they will see absolutely nothing. The deep sky will be entirely black. Every other galaxy, every supercluster, and every massive filament of the cosmic web that we can see today will have been pushed permanently beyond the cosmic event horizon. They will have been redshifted into total, impenetrable invisibility. The future night sky will be a dark, empty void. To those future observers, the universe will appear static, lonely, and incredibly small. They will look out into the dark and reasonably conclude that their single local galaxy is the entire universe. They will have absolutely no visual evidence that the cosmos was once teeming with 2 trillion other galaxies. But the isolation goes even deeper than missing galaxies. Earlier we discussed the cosmic microwave background, the ancient glowing wall of light that surrounds us, proving that the universe began in a hot, dense state. That residual whisper of creation is the ultimate foundational proof of the Big Bang. It is the direct physical evidence that the cosmos has a shared explosive history. In the far future, that evidence will be destroyed. Because the cosmic microwave background is made of light, it is also subject to the stretching of space. Right now its temperature is 2.725 Kelvin. It is a faint microwave signal. But as dark energy accelerates the expansion of the void, those ancient photons will be stretched further and further. In 100 billion years, the wavelength of the cosmic microwave background will be stretched so incredibly wide that the energy of the photons will drop below the ambient threshold of empty space itself. The light will become physically unmeasurable by any conceivable instrument. The echo of the Big Bang will fall completely silent. This means that future civilizations will have no empirical way to discover the true origins of the universe. If a scientist living 100 billion years from now tries to construct a model of cosmology, their telescopes will tell them that they live in a dark, infinite and eternally unchanging void containing only a single galaxy. They will not know about cosmic expansion. They will not know about the hot, dense early universe. They will not know about the violent fraction of a second of cosmic inflation. The universe is not just carrying galaxies away. It is actively erasing the evidence of its own birth. The cosmos is permanently hiding its history. You might feel a sudden, quiet heaviness at this realization. There is a deep existential weight to the idea that the universe will eventually empty out, and that the grand, beautiful complexity of the cosmic web is a temporary phenomenon. But this is not a tragedy. It is important to remember that there is no malice in this process. The universe is not ending with a sudden, violent catastrophe. It is simply executing the indifferent laws of thermodynamics and cosmic expansion. It is a quiet, natural consequence of the physics that govern reality. The fading of the universe is just the slow, steady exhaling of space. Instead of dread, this realization should instill a profound sense of awe at your exact position in time. You are incredibly lucky to exist right now. We live in a uniquely privileged cosmological window. We happen to exist in the exact, brief fraction of cosmic history where the universe is still highly readable. We arrived late enough that stars had time to forge the heavy elements necessary to build planets and human bodies. We arrived late enough that the hot, blinding plasma of the early cosmos had cooled into a transparent void, allowing us to see across the distances. But more importantly, we arrived early enough that the sky is still full of clues. We woke up in the universe before the evidence was erased. We can still see the 2 trillion galaxies before they slip over the horizon. We can still detect the faint, ancient glow of the Big Bang before it stretches into silence. We can still map the large-scale structure of reality and mathematically deduce the terrifying, violent geometry of cosmic inflation. We live in the era of visibility. The window is shrinking, and one day it will close completely. But right now, the window is wide open. The information is still here, raining down on your roof every single night, waiting to be caught by our telescopes. The honest uncertainty of cosmology is that we will never be able to see the entire picture. The boundary of light and the acceleration of dark energy guarantee that the vast majority of existence is permanently locked away from us. We will always be operating with incomplete information, but the fact that we can figure out the rules of the game even while the board is being actively dismantled, is the greatest intellectual achievement of our species. You are a small thing, sitting in a quiet room, resting on a tiny planet. But you are a small thing that knows exactly how the universe was born, and exactly how it will fade into the dark. And while the sky is slowly emptying out, our investigation into what remains is far from over. Because even though the wall of light blocks our vision, the universe possesses another force. A force that does not care about the speed of light, and does not care about the fading of the stars. If you rely entirely on your eyes, the universe is a closed and shrinking room. Throughout this investigation, we have followed the absolute limits of light. We have established that the finite speed of light, combined with the accelerating expansion of space, creates a hard mathematical boundary around your reality. We have looked back to the absolute visual edge of the cosmos, hitting the impenetrable glowing wall of the cosmic microwave background. That ancient fog of plasma sits exactly 380,000 years after the Big Bang, permanently blocking our vision from seeing any further back into the history of creation. Light is a fragile messenger. It can be scattered by plasma. It can be stretched into invisibility by dark energy. It can be permanently outpaced by the expansion of the void, burning the bridge of causality between us and the trillions of galaxies slipping permanently over the cosmic event horizon. If the story of cosmology was entirely dependent on light, this is where the story would end. We would be forced to sit in our quiet, isolated bubble, watching the galaxies fade into the dark, forever walled off from the true immensity of the structure we live inside. But light is not the only messenger in the cosmos. The universe possesses another force. It is a force that does not care about the blinding fog of the early plasma, and it is a force that is not extinguished by the stretching of the dark. Gravity. We are used to thinking of gravity as a simple pull, the invisible tether that keeps your feet resting firmly on the floorboard beneath you, or the invisible chain that holds the Earth in its reliable orbit around the Sun. But in the mathematics of general relativity, gravity is not a tether. It is the physical curvature of the fabric of space-time itself. When the universe was born, and the terrifying, violent fraction of a second known as cosmic inflation took hold, space did not just expand smoothly. The exponential stretching of reality was so forceful and so unimaginably brutal that it sent massive, violent shudders through the very fabric of existence. Think of striking a massive iron bell with a heavy hammer. The metal does not just move, it vibrates, it rings. During inflation, the universe rang. The violent stretching generated ripples in the geometry of space-time, microscopic distortions that propagated outward in every possible direction. These are called primordial gravitational waves. These waves are not made of light, they are made of space. Because they are made of space itself, the primordial plasma of the early universe could not scatter them. The wall of light that blinds our telescopes posed absolutely no obstacle to them. These ripples passed straight through the blinding heat of the Big Bang, completely unimpeded, and they have been travelling across the expanding cosmos for 13.8 billion years. They are passing through the room you are sitting in right now. As you rest in your chair, feeling the perfect stillness of the air around you, microscopic waves of ancient gravity are quietly passing through your body. They are stretching and squeezing the physical space inside your room by a fraction of the width of an atomic nucleus. You cannot feel it, but the room is breathing with the residual ringing of cosmic creation. For the entirety of human history, we have been completely deaf to this ringing. But right now, at this exact moment in our technological evolution, that is changing. We are no longer just looking at the universe. We are building the tools to hear it. This is not speculation. This is engineering. Right now, ground-based observatories and high-altitude experiments like BICEP and the Simons Observatory are actively scanning the cosmic microwave background. They are not looking for light in the traditional sense. They are looking for a highly specific twisting pattern in the polarization of the ancient light, a pattern known as B-mode polarization. This pattern is the literal fingerprint left behind by primordial gravitational waves as they rippled through the plasma wall 13, 8 billion years ago. But we are also building instruments to bypass the wall of light entirely. To look directly past the edge of the observable universe, scientists and engineers are preparing the Laser Interferometer Space Antenna, or LISA. LISA is not a telescope made of glass and mirrors. It is an instrument of terrifying scale and precision. It consists of 3 separate spacecraft that will be launched into the freezing dark of the solar system, trailing behind the Earth in its orbit around the Sun. Once in position, these 3 spacecraft will drift apart, forming a perfect equilateral triangle in the vacuum of space. The distance between each spacecraft will be 2.5 million kilometers. Give that number the space it demands. 2.5 million kilometers. Across this staggering empty gulf, the spacecraft will continuously fire lasers at one another, measuring the exact distance between them to a precision smaller than the diameter of a single atom. They will float in the quiet dark, waiting. When a primordial gravitational wave, a ripple from the very first fraction of a second of inflation, passes through our solar system, it will subtly warp the space between the spacecraft. The lasers will detect that microscopic shift. LISA is a massive, incredibly sensitive ear designed to listen to the vibrations of the universe before light even existed. This changes the fundamental limits of our reality, because gravity does not care about the cosmic event horizon. Earlier, we established that massive structures lurking entirely outside our observable bubble are exerting a gravitational pull on our local galaxy clusters, a phenomenon known as dark flow. The light from those massive architectures will never reach us, permanently trapped behind the accelerating expansion of dark energy. But their gravitational anchor remains. Gravity bridges the gap. By shifting our cosmology from the electromagnetic spectrum into the gravitational spectrum, we are turning the edge of the universe from a hard, impenetrable wall into a permeable membrane. We are building the capacity to hear the shadows from the outside. We are actively constructing the machinery required to listen to the regions of space that have been permanently deleted from our visual reality. This is the forward momentum of our species. The story of the cosmos does not end with the shrinking of the light. The museum is closing its visual doors, but we are learning how to press our ears against the glass. The search for primordial gravitational waves is ongoing. The waves remain elusive, slipping through our current detectors like ghosts. The data is still flowing in, the models are still being relentlessly refined, and the next generation of instruments is still being assembled in clean rooms around the world. We do not have the final answer. We do not know exactly what the ringing of the early universe will sound like when we finally capture it, or what terrifying new structures it might reveal, lurking just beyond the edge of our 93 billion light-year bubble. The investigation is actively unfolding. Out in the deep dark, the expansion of space continues to accelerate. Dark energy continues its patient, relentless work, stretching the fabric of reality and pushing our cosmic siblings further into the freezing void. The night sky above your roof is still slowly emptying out, shedding its ancient light one fading photon at a time. The grand, quiet erasure of the cosmos proceeds without our permission, indifferent to our presence. But locally, inside your room, The air is still. The gravity of the earth is still holding you safely in your chair. The walls around you are solid. You exist in a uniquely privileged window of time. You woke up in the universe, while the evidence of its violent birth is still raining down on the roof of your home, and while the light of 2 trillion galaxies is still bravely fighting its way across the expanding ocean of space to reach your eyes. You are a temporary arrangement of stardust, sitting in a quiet room, trapped inside a massive shrinking bubble of causality. You are a remarkably small thing. The universe is an impossibly enormous thing, and the fact that you can sit in the dark, close your eyes, and perfectly understand exactly how that enormous universe was born, and exactly how it is hiding itself from you, is the most interesting thing we know.